when we talk about a binary of black holes or a binary of neutron stars orbiting each other, the main signature of the gravitational waves comes at twice the frequency of the orbit, basically. And that's sort of each time one of the objects passes, say, in front of you, that sort of stirs up another cycle of the gravitational wave signal, which eventually reaches the observer. But just like you have, say, a wine glass has a particular resonant frequency, and you see, say an opera singer sings the right note and the wine glass can shatter. So one of the research projects that I worked on was understanding how the energy of the orbiting system, when the orbital frequency, the frequency of the orbits matches up with the natural frequency of an individual star, that can transfer energy into the star's vibration. And so this can do some pretty dramatic things, like similar to how a wine glass can shatter if you hit the right note. The solid crust of the neutron star might shatter if it sweeps through the right frequency in the orbit. And so some collaborators and I sort of worked through that might cause some high energy flares that you could see in association with a gravitational wave signal or independently even. And so these sort of oscillations taking away energy from the orbits can also, if they're strong enough, and it has to be a huge amount of energy to affect the gravitational wave, but they can also drive the stars to merge earlier. So they can, instead of spending the energy in orbiting, the energy goes into the vibration of the stars instead, and that actually leads them to crash together. So they're losing energy to gravitational waves, and then they lose extra energy to this vibration. And so that would cause them to crash together earlier. Then there's a third part when the vibration can come in, is that the stars crash together, and this new object that's formed from the two stars crashing together itself, like the the new object that's formed by the two stars crashing together, like the wine glass or like, say, a bridge, has sort of a frequency that it will like to vibrate at. And there's actually, from this rapidly rotating object of the two orbiting stars that have collided, it may have an instability that causes it to bulge out and emit more gravitational waves from the spinning object that's created from the collision. And so being able to observe those gravitational waves would tell us more about the neutron stars after they've collided, which is a different scenario from before they've collided. So it's giving us sort of a new tool to learn about what's happening in the neutron stars, both from how they change as they're approaching each other, and then from how either they maybe live for a while emitting this vibrational mode, emitting energy at this particular signature frequency, or maybe they collapse promptly to a black hole.